Hello, welcome back. Um, we'll continue on this, okay? Just like we promised. Um, so yeah, we we are trying something new here, okay, in physics because in economics, yeah, we discovered something that was not there before for 100 years. We discovered an error in Professor Alfred Marshall's supply and demand curve, and we corrected it, right? So yeah, physics same. We challenge. Mathematics same. We are like Goliath. I mean, not Goliath. David. Okay, we are Davidans. Davidans. They are Goliathans. Okay. Yeah, we challenge. Okay. We believe we can discover something new that has not been discovered for centuries. All right. That's what we are doing here. Okay. So this green is not quite clear, so I'm gonna start using black. Okay. Oh boy. For all we know, is this energy is constant. You have energy total is equal to energy total is equal to maximum potential energy plus maximum is equal to maximum kinetic energy. What is maximum potential energy? M G H height, okay, is equal to half M V max squared, right? We know this much, all right? If it's halfway in the middle, is equal to M G Y plus 1/2 M V squared. Okay, this much we know. All right, so now we suspect this Y is equal to some kind of a sine t. Okay, in terms of time, sine wave. That's our best educated guess. Okay, I have never seen any equation, any this narrative before. I took a lot of physics class, but nobody talked about this. I haven't seen one. Have you? Maybe you have. Okay. This bounce of basketball, perpetual motion in a vacuum. I haven't seen one like that. Okay, so I mean equation wise, so we are trying to derive that for the probably for the first time or not. Doesn't matter. Maybe some obscure literature. Maybe it's already there. We don't care. Okay, we don't have time to look up. Okay, so maybe it's in the internet. Okay, perpetual motion or bouncing ball. I don't know. Well, I want to derive it. Okay, because I have time. I don't know about you, but I do. It's like kind of Valentine weekend, but I I'm here alone, so Saturday night academic fever, I guess. I'm such a nerd. Yeah, but that's fine. Yeah, we enjoy what we are doing here, so it's all good. Ah, boy. Quartic in terms of T. That's something new. Oh boy. So we are talking in terms of Y and T. Okay, so we gotta get rid of everything else. All right. Okay. Let's get started. All right. We have 3 hours to do this. Okay. 3 hours. All right. We need Y and T and nothing else. Because that's our goal here. Okay. Expressing Y in terms of T. Okay. And some other constants. All right. Now it's getting cold. I'm gonna turn the heater. Okay. So. Ah. Good. Heater is on. Whew. It's getting a little bit chilly. And we said, oh yeah, you know what? We are doing humanology here. No physics, mathematics. You're supposed to know that. But it turned out that I don't know enough mathematics and physics because I forgot. So we're backtracking, okay? I'm gonna use brown, okay? So, all right, what is V? V is equal to, you're dropping a ball, all right? So V0 is 0, okay? So, okay, that's V. But not exactly because this equation holds true when the ball is dropping. But what if it's bouncing up? Okay. Um, so this equation only works on from time 0 when you start dropping, and then time ground level. Okay. After that, this equation doesn't work. Okay, so we have to find a generic equation of perpetual motion. All right, so this is a challenge. So if we go like this, okay, time 0, velocity was 0, and then it goes up like this as a parabolic motion, right? We call it time ground level or time floor level, because G is like gravity, you know. So at the floor level, yeah, it reaches this maximum speed. Okay, it's a parabola in terms of time, velocity. Okay, when it reaches the floor maximum, and then when it bounces up, it will be mirror reflection Okay, so it will be like this. Time, ceiling, ceiling, floor, okay? And it will bounce again, right? So yeah, it will go up there like this. So it's not exactly sine curve. It's like this dancing spiky thingy, okay? Yeah. So this is 2 times of time. Well, this is like 2 times of time floor, okay? This is 3 times of time floor. This 2 times of time ceiling, okay? Yeah, it's spiky. It's not sine curve. All right, we got it. Okay, so but we are suspecting why this height of this ball in terms of time, is this sine curve? That's our suspicion, our guess. It may not be. Okay, it may not be. We're trying to figure it out. All right, so so from here to here, the velocity increase, okay, parabolic fashion, right? And when it start to bounce up, the velocity decrease in a symmetric fashion. So it has to be this parabolic line again. And when it hit the ceiling, yeah, it repeats this parabolic increase of velocity. Okay, so yeah, that's that. All right. What is the function of this funky line? Well, if it's not differentiable because it's spiky point. So it has to use this Gauss function or step function. It's not going to be very pretty, okay? So you can take a shot at it, okay? So maybe some Heaviside step function, kind of combination of that. I mean, what is this function, man? How do we express this? We have parabolic line here, right? Then we have another parabolic line. So to express this in a nice mathematical function, we are Alice in Wonderland, okay? The rabbit hole it goes down deeper and deeper. Oh boy. But I think it's worthwhile, okay? So oh boy. You know what? Let's go back to basics, okay? We're gonna erase all this. We're just having fun with mathematics, alright? So ugh. It's good that today's Saturday. We have time, enough time at last. Okay, we have time all for ourselves. So we have this parabola. Okay, one parabola. Okay, y is equal to x squared. Right? But what if we want a function that looks like this? In a different color, like this. Dancing function, okay? Woo! How would we express this function? Like a crown, spiky crown. How would we express that function? It's like from -1 to 1, it's like y is equal to x squared. Okay? From here to here. From here to here, we have y is equal to what? X minus 2 squared, okay? From here to here, we have y is equal to x minus 4 squared, okay? How do we express this? Well, let's do this. -2, okay? So from here to here, y is equal to x plus 2 squared, okay? You see, I'm drunk, but I can do mathematics, all right? Okay, so yeah, I'm in control. Okay. We want to express this collection of functions in one simple equation, okay? So that's our challenge. First is some kind of brand new mathematics, okay? Maybe some Gauss ceiling floor function or Heaviside step function, something like that. Some combination of that, okay? It's not differentiable. We don't care. We don't care. We don't care about differentiability. We are not statisticians. Okay. No, we are not analysts. We are humanologists. We love this function. Yeah, it's spiky. It's not differentiable. Well, whatever. So what? It's still a realistic function. So bouncing ball. Okay. We don't care about differentiability. We just want to express in mathematics, in mathematical equation. That's all we want, okay? Ah, boy. We want to find out a function where from -1 to 1, it's 1 or 0. From 1 to 3, it's 2. So y is equal to x plus 0 squared, okay? When this is, because x is between -1 and +1, all right? -1, +1. Then this guy should be 0, okay? And this guy should be 2 when it is between 1 and 3, okay? And this guy should be 4 when it is between 3 and 5. All right? Can you see all this? I need you to. Okay. Yeah, you can see it. when x is between -1 and -3, okay, this guy should be 2. Between -3 and -1, okay? We gotta find that formula, right? So, I think we got it though. -2, what is -2? 1 minus 3. 0? Well, let me see. Oh. This is not gonna be easy. We have to take a break, okay? Because I need to think about this. You have to find a perfect equation. It could be ceiling floor function like Gaussian, Heaviside step function, something like some combination of that, okay? So we have to find this crown equation, okay? One simple mathematical equation that expresses this crown. Woo! Okay? And we're gonna take a break, and yeah, you will think about this, I will think about this, and we'll get back. We'll regroup, okay? So we get back, okay? All right, let's take a break. Oh, this is not gonna be easy. Okay. Okay. Ah, boy, this is not easy. So, we have to take a step back. Okay. So, we're gonna have to generalize a little bit. All right. So, boy, what the hell am I doing in this Valentine's weekend? Weekend before the Valentine. It's like February 2019, the weekend before Valentine. Oh, what am I doing? Well, it's better than getting some STD. So, I mean, if I go to a bar, I'm not gonna get any girl anyway. But whatever. Yeah, it's good to be single. I don't get any STD, so whatever. Okay, we continue on this. Okay, so sampling. Okay, the sampling. You have this x-axis and y-axis. Okay, let's use black. It's right here. From 0 to 1, you take this nice graph, parabolic. Y is equal to x squared, okay? From 1 to 2, you're sampling. You know what? I want a straight line here, like this. From 1 to 2, it's like y is equal to x, okay? From 2 to 3, I want something else. How about some function like this, whatever function that may be. Okay? It's a sampling, okay? Depending on the interval, okay, we are using different functions. That's what we are trying to express in a simple function, simple one equation, okay? So how can we express this in a simple, nice mathematical equation? Okay. We need some creative thinking. Okay. I'm not sure this kind of mathematical thought has ever been done before. I took many mathematics classes and I haven't seen any so far. So we're gonna make it happen. Okay? Sampling. Maybe it's been done before somewhere by somebody, okay? But we don't have time to look up in the library or online. We don't even know what kind of search term. Yeah, maybe mathematical sampling. Yeah, maybe sampling. Okay, it's kind of in the sound engineering. You sample this rhythm, you this curve of this. Yeah, I'm kind of familiar with that because I worked with synthesizer. Okay, when I was making music for my movie. Yeah, I purchased many synthesizer synth, you know. Yeah, I'm kind of familiar with that, okay? So yeah, perhaps it's been done before, okay? We don't care. We'll just come up with something new. Okay, maybe we'll rediscover. It doesn't matter. Okay, so well, we'll start with Gaussian function. Okay, Gaussian ceiling floor function. Y is equal to ceiling of x. Okay, when it's a ceiling. Okay, let's do flooring. flooring of x. Okay, so between 0 and 1 is this, between 1 and 2 is 1. Okay, it's a step function. Okay, you are rounding it down. Okay, this is 0 0.1, 0 0.2, 0 0.9, 0 0.7 is 0. You are finding the closest integer that is less or equal to that number. Okay, that's a floor function by Gauss. Something like Carl Friedrich Gauss, something like that. The German mathematician, right? So we have that, and the sampling function, well, so we will have set of function, right? y1, y2, y3, okay? With an interval from 0 to 1, 1 to 2, 2 to 3, okay? So, this function y is equal to y1 if x is between 0 and 1, okay? y2 if x is between 1 and 2, okay? So yeah, we kind of got it, okay? Y is equal to yn if x is between kind of getting cold. Let me zip it up and I'll be right back. I'm getting too cold. Yeah, I have to put on these pants, another layer of pants, sweatpants. Oh boy, it's getting too cold. I'm gonna put on my nightcap and not mascara but scarf. All right, just trying to be funny. I have to zip it up. Oh, my jacket. Okay. Now I'm warm, right? Where's my slippers? Maybe it's here already. I don't know. Whatever. Okay. So y is equal to yn if x is between n minus 1 and n. Okay? So this is not exactly mathematical equation because we have this if. Okay? It's a quasi mathematical equation. Okay? We have this if operator. All right? So we want to get rid of that if. Okay? We want to make it purely mathematical equation. Okay? Like in Kronecker delta, Kronecker delta is like delta ij is 1 if I is equal to j, 0 if I is not equal to j. Okay? So how can we get rid of if here? Okay? It's this. Okay, delta Kronecker delta ij is equal to I j I think it's XOR, right? Let me look it up. XOR. Maybe X nor. Okay. Okay. It's X nor, right? All right. Okay, so it's X. It's not X or, but it's X nor, and it is conventionally denoted as this. Okay, dot, circle dot, X nor. Okay. Yeah. So we have that. We got rid of that. This if. Okay. So. Oh boy. Okay, so how about this? y is equal to boy. Yn, okay, times, this is not 1 2 3, but p1 p2 p2 p3, okay, because we have to make it general, right? So between p uh, something like this, okay, so boy. Sorry, we have to erase everything. We want to multiply by 1, okay, so when it's the time you're waiting in a line, okay, you're all stand-up comedians, and when it is your time, then you are it, okay, so oh boy. Alice in Wonderland, oh boy. Function 1, function 2, function 3, okay, you're stand-up comedians, okay, so we do it one by one. You get 2 minutes or 3 minutes or 5 minutes, okay, starting and ending time, one by one. You're lining up. Now comedian number 1, you're on stage, you do whatever the hell you want to do in this stand-up comedian routine. Your time is up, you're out. Stand-up comedian number 2 is more famous, so I'm gonna give you more time, you know. That's what we are doing here, okay? You do whatever the fuck you want. Your stand-up fucking comedian routine, okay? So this generic function is equal to f n times is a p1 minus p0, okay? The length of this time gap. Maybe you're laughing at me. Maybe you know how to express this, okay? If you're good at mathematics. I guess I'm not that good at it, okay? So it's a very simple equation. Oh, it's taking too long. Why don't we take a break, okay? Because I need to step back and think. Oh boy. Okay, we have to erase again. Okay, because let's be more concrete rather than too being too general. Little baby step at a time. Okay, so we are trying to find a function where from 0 to 1, 1 to 2, yeah, it's a parabolic equation. Okay, from 1 to 2 is y is equal to x. Okay, from here to here, and from here to here y is equal to x. Okay, that's what we y1 and y2. Okay, so that's what we have to trying to find out. Okay, so y is equal to x squared when y is equal to x if x is between 0 and 1. Okay, if x is between 1 and 2. Okay, we want to get rid of this if and this bifurcation. All right, trifurcation. We want to express one simple equation. Okay, so that's what we are trying to do. It could be x or x nor, some logical function, whatever. We just want simple equation. All right, so how do we do that? I have never seen anything like this before. Okay, so maybe it's been done before. All right, so but we just want to exercise, right? Okay, take a break. We'll be back. Okay. All right. Okay, we are back, and let's take another step back and explore some more of this XNOR function. Okay, in electronics, if you're an electrical engineer, you know this function XNOR. Okay, Boolean algebra, right? So let's make some connection between Boolean algebra and algebra. Okay, so we're going to define a brand new function, all right? Y is equal to 0 and 1 if function of x, okay? Fx is equal to 0 and 1. If x is equal to 0, then it's 0. If x is not equal to 0, okay? X can be negative 10, plus 10, whatever, okay? It's a unary operator, okay? We call it z, zero function, all right? How can we mathematically define this, okay, algebraically? Well, one way to look at it is this. Maybe x over x. So if x is not equal to 0, it's like x is 3, 3 over 3, yes, 1. But what if x is 0? 0 over 0? That's undefined, right? Boy. Yeah, so that's the Kronecker delta problem, okay? We cannot quite define it in algebraical term. Kronecker delta is very philosophical concept. Boy. Because XNOR is like this. You have two input, okay? Delta ij, all right? What if ij is not just 1 and 2? I mean, 0 and 1. What if I and j could be like 2 and 3? Okay? We don't like this bifurcation, so we want simple equation, okay? So, but if we define equation like this, okay, we call it zx, right? So Kronecker delta can be thought as Kronecker delta ij is something like this, okay? Z Okay. Zero function. If z0 is 0, okay, z anything else than 0 is 1, okay. We are not making any progress. We are not making any progress because we try to get into this bifurcation and we still have bifurcation here, okay. So so I is 1 and z is 2, okay. What is 1, z1, 1, x nor, how about 2? Well, it's 1. So they're the same, x nor, so it's not quite working. Man. No, this is wrong equation, okay? Boy. Chronicle data. We want to find an equation, simple equation that does not have any if, okay? We don't want this bifurcation because it's not quite algebraic. It's more like English, you know. We want mathematics, okay? We don't want this hybrid like that. Okay. In the binary world, yeah, it's like this. It's I, x nor j. If I and j are just zeros and ones, okay. X nor table, okay. Okay, x nor, right? 0, 0, they're the same, so 1. 1, 1, 1. 0, 1, 0. Okay? This is x nor table. X nor. Okay? It's the opposite of x or. Okay? So x or, oh boy, x or is like this. In set theory, minus a okay, so XOR is like this. Okay, you have set A, set B. Okay. XOR table is like 0, 1, 1, 0. Okay, so A and B. Yeah, this is XOR, okay. Minus A union minus B, okay. X NOR, opposite of that, okay, is AB or minus A minus B, okay. Yeah, so that's X NOR. So basically, we want to reduce all the numbers to 0 and 1, okay? Not exactly. You may be wondering what I'm thinking. Oh boy, I don't know what I'm thinking. I'm just. Does this have a purpose? Yes. It's a mathematical experiment. Okay. I hope I don't go crazy after this. Don't worry. Okay. I have good control. Right. So, don't worry. Ah boy. Just some weekend. Valentine's Day weekend, okay. Spending by myself. I have no problem with that. Just it's taking a very long time. Okay. I'm gonna have some Tums because yeah. Okay, we clear the deck, okay, by erasing all this, but we are not done yet, right? The purpose of all this is we want to find out Kronecker delta function in a simple one line equation instead of bifurcating. Okay, that's what we're trying to do. How we get there, how did we get here? Well, we're talking about a lot of different things, but It's like what Jesus said, right? Yeah, how do you get Holy Spirit? Yeah, with wind blows. We don't know. God works in a mysterious ways. We just do our job, okay? So, chronicle delta man, tricky concept. So, chronicle delta function is like this, okay? You have A and B, okay? And it's a Boolean function, okay? It's either 1 or 0. 1 or 0. When is 1? If A is equal to B. When is 0? When A is not equal to B, okay? So, we don't like this bifurcation, okay? So we want to find out a simple one-line equation that captures this concept, right? A can be anything. A can be 3, B can be 5, all right? If they're different, it has to be 0. If it's 10 and 10, then it should be 1, all right? So how can you express that? Yeah, you can subtract this 2, right? So A minus B, okay? And we have z function, 0 function. If it's not 0, then yeah, it has to be 0. So this z function is this, okay? Z function okay? Can you see this? Yeah. Z of x is like 0 if z is 0. 1 if z is non-zero, okay? This is the z function, okay? So three minus 5 is negative 2, okay? So z function of that is not, it's not 0, okay? So it's 1, okay? Okay, we got it. Okay, so logical negative, okay? The Boolean function negative. Logical negative is a unary function where it converts 0 to 1 and 1 to 0, all right? We got it. Kronecker delta A, B is this, okay? We got it. But we didn't quite improve Kronecker delta function because we still have this bifurcation. Okay, so our next step is to reduce this z function into a simple algebraic or Boolean function. Okay, so that will be our next step. A and B are different, then it's non-zero. Okay, non-zero, then it's 1. And logical negation of 1 is 0. Okay, so A, B different, yeah. Negation of 1 is 0. So we got it. Okay. Okay. A and B are same. Okay, then Z is 0. Z is 0 is 0. Logical negation of 0 is 1. Right there. We got it. Okay. Now, how can we express this z function in terms of one line, single line algebraic equation? there we are next question, okay? Once we have that, then we have delta function. This chronicle delta freaking bitch function. Okay. What a bitch. Yeah, chronicle is smart guy, I guess. He recognized the significance of this function. It's a very challenging function, okay? Now we are challenging mathematics, right? Once we figure this out, and we go to the next step, right? So, boy. We'll take a break, all right? So we find out about this, okay? All right. Okay, I think I made some progress here. Okay. Boy. What if z of x is equal to x times x plus 1? Okay. When z is 0, right? Yeah, 0 times 1 is 0, right? When z is 1, x is 1, yeah, 1 times 2 is 2. We need to reduce that. So we'll just divide by x plus 1. Or x plus 2. When x is 3, okay, 3 times 4. This is not working. Okay, if x is 0, yeah, 0 times 1, yeah, is 0. Because that's what I was thinking, okay? But then you're 0 dividing by 0. What the hell is that? It's supposed to be 0. Maybe it's just impossible, okay? Maybe we are trying to solve an equation or solve a problem that has no solution. Okay. Is there a function like this? It's like this, okay? When x is 0, I'm sorry, this is x, okay? X is 0 is 0, okay? When x is anything else is 1. Okay? When x is 0 is 0. When x is anything else than 0, this function is 1. Alright? When x is minus 1, minus 2, plus 1, plus 2, it's all 1. Alright? But when x is 0, then it's 0. This function z, 0 function, okay? Ah, boy. So we didn't quite make any improvement because we just we moved the bulk to someone else from delta to z, okay? Yeah, delta function now is a single linear, one equation without bifurcation. But now z is the bifurcated function, okay? Ah, boy. When a and b are equal, then z is 0. So when they are 0, it's 1. Okay, so a is not equal to b. So we got this, okay? Yeah, it's a progress, okay, in a sense, because we reduced it to a simpler function, all right? Yeah, pat on the back, okay? So we cannot quite express this algebraically, all right? Maybe it's impossible, right? It's not continuous function, okay? There's this leap, you know. We can approximate it, right? Can we make some Boolean algebraic equation, XOR gate, NOR gate, whatever? Okay. We know x times x multiplied by x plus 1, okay? If x is 0, then yeah, this guy will be 0, right? But if x is something other than 0, then it will be some other non-zero number. We know that. I mean, unless x is minus 1, right? Ah, x could be minus 1 though. Ah. Can we define 0 over 0 as 1? Is it okay if we do that? If we do so, then we can solve this equation, okay? So, let's do this, all right? Let's say 0 over 0 is 1, okay? We're gonna define new mathematics, all right? True 0, okay? It's not some limit or nothing like that, okay? So, and 0 over 1 is what? 0. And 0 over 1 over 0 is equal to infinity, okay? Okay, let's do that, okay? Just like Einstein, okay? We're gonna defy the convention, right? Yeah, Einstein said, yeah, time is not absolute, it's relative. So we are defying the convention. You're a rebel. Okay, let's do that. If we have that, okay, z of x is equal to x over x Okay, we have 0 over 0. It should be 0. Maybe this. Logical negation. Okay. When x is 0, 0 over 0 is 1, then logical negation of 1 is 0. When x is, no, it always become 1. Oh, it's so horrible. How about this? X times x plus 1. 0, 0, 1. If x is 1, 1 times 2. Man, it's not quite working, okay? Oh boy. We want to find some consistent mathematical world where we can define Kronecker delta without bifurcation, right? So that's what we are after. Oh. Okay. This is a challenging question. We want to find some algebraic or Boolean algebraic equation, one simple line without two lines, okay? We want to reduce this two line into one line. That's what we are trying to do, all right? Because we know delta ij, okay, is equal to logical negation of z of I minus j, okay? We got that far, right? ij can be any number, like 3, negative 10, whatever. It's an equivalent problem, okay? So yeah, I learned this in computer science, theoretical computer science. Yeah. You have a big problem, you reduce it into a simpler problem, Simpler but equivalent, okay? If you find solution to this simpler problem, then you have found you solve the more complex problem because they're simpler but it's equivalent, okay? So yeah, theoretical computer science is good, very cool stuff. Okay, it's advanced mathematics, okay? Yeah, I took class in computer programming language and yeah, good stuff, very cool stuff, okay? Yeah, that's what we're doing here. Let's take a break, okay? Because I'm hitting the brick wall, okay? So we'll take a break and we'll think about this, okay? You too, all right? So, yeah, let's think about this, okay? All right. Ah. Man, what did our what did we get ourselves into? Oh boy. Mathematical labyrinth. We just found ourselves to be a victim of this mathematical maze labyrinth. Okay. We like adventures, so we keep on going. Okay. Simple equation, simple problem, but we have no idea where we are. We have no idea where we are. Let me switch out some drinks. Man, it's not easy. Okay. Can you help me? I'm lost. Can we express this in one simple equation, one line, not two lines, one line? That's what we are trying to do here. Help me, please. I need some help. I have no idea, right? I mean, in programming language, yeah, you can program such that, yeah, if is x is not equal to 0, x is what, 4, 3, 5, yeah, you just simple function, right? You return 1. When x is 0, yeah, you return 0. It's an if else statement. But algebraically, how do you express that? Is it possible even? Maybe it is impossible. Okay? Okay, then if it's algebraically impossible, yeah, let's use different mathematics like Boolean algebra. Okay? Is it possible to express this somehow? With a combination between Boolean algebra and algebra, traditional algebra. How do you make number some non-zero number to 1? Yes, 3 divided by 3, right, is equal to 1, okay? Or 3 minus 2 is equal to 1, okay? And we know 0 times some number like minus 1 is also 0, right? We also know 2 to the 0 is also 1, okay? So let's take advantage of that, okay? How about this? 2 to the x, okay, is equal to 1 or some non-negative or some other number. If x is equal to 0, okay, and some number um, some positive number when if x is not equal to 0. Some different number than 1, okay? Okay, so, all right. Whew. Okay, we resort to this exponential function, okay, hypothetically. We have to try all different kinds of, we gotta get all the help we can get, okay? Let's try this exponential function, okay? Boy. So 2 to the x. When x is 0, one if x is equal to 0. Some other than 1 if x is not equal to 0, okay? It could be infinity, it could be 2 to the 4th with 16, or 2 to the negative 1 is more like 0.5, 1 not, okay? But 2 to the x is never 0, okay? So this 2 to the x, y is equal to 2 to the x, okay? It's never 0, okay? So we got some improvement there because we got rid of 0. We hate 0, okay? I we don't hate it, but 0 is a very difficult number, okay, to deal with. Okay? I'm not sure we'll get there, okay? I'm sorry. Maybe we're barking at the wrong tree, alright? We want to express this equation, bifurcated equation, into one single equation. That's what we're trying to do, right? Ah, boy. How about this? 0 times 0 over 0. Okay, we can define this tentatively as 1. All right. Okay. So this guy is 0, right? How about 1? 1 times 1 over 1 is equal to 1. Okay? So 3 times 3 over 3. Well, that's 3. That's not 1. But we can divide this by 3. Okay? To make it into 1. Alright? Okay. We are running out of space again. So maybe we are getting close, alright? Okay, so 0 times 0 over 0 is 0, and you divide by 0 and it becomes 1. Oh. 3 times, so this is 0 times 1 is equal to 0. 3 times 3 divided by 3 is equal to 3 times 1 is equal to 3. Okay? Ah, boy. And we want to make this into 1 and this, while we're keeping this as 0. Okay? Ah. Man, this is so hard. How about 0 times 2 to the 0, something like that. And we're just experimenting, exploring different possibility. Okay. Okay. 0 times 2 to the 0, or 3 times 2 to the 3. Okay. This is equal to 0 times 1 is equal to 0. This is equal to 3 times 8 is equal to 24. Okay? Ah, boy. Maybe we are barking at the wrong tree. Maybe it's impossible to express this bifurcated equation into one equation. Maybe. Okay? It's so elusive. It's like it looks so close. I don't think it's very difficult, but it is very difficult. How about x times x over x? If it's 0, 0 times 0 over 0 is equal to 0, right? If it's 3, uh, 3 times 1 is 3, so we have to divide by 3 again, and then 0, 0 over 0, okay, 0 times, this is fucking zombies, man. If it's 0, 0 times 0 over 0, which can be 1, okay? So this becomes 0 times 1 is 0, and you divide by 0, and it still becomes 0. Oh, it's no good. It's torturing me, okay? X times 2 to the x. I have no idea, okay? I'm sorry. Have some limit function. Ah, boy. We gotta integrate Boolean function somehow, okay? So, how about x? In Boolean function, all these numbers has to be either 0 or 1, okay? When you have Boolean operator, okay? So to convert algebraic numbers into Boolean numbers, you have to convert that into 0 and 1, okay? So it's like 0 multiplied by some algebraic number, or you divide some algebraic number like 3, divide by 3, it becomes 1. And here it becomes 0, okay? Yeah, so that's the conversion process between algebraic universe into Boolean algebra universe, okay? You're converting this to 0 and or you're converting to 1, okay? So okay. Oh boy. Yeah, two different languages, okay? Boolean algebra and algebra, right? Algebra, you have all numbers like 3, 5, and Boolean algebra, you have just 0 and 1, okay? So that's the difficulty, is we are lost in translation, okay? I love that movie, Lost in Translation, yeah, okay? So we'll take a break and we'll get back to this, okay? Oh boy, I have no idea. Okay, we're back. Okay, in Alice's Wonderland right here, because we are dealing with zero. Ladies and gentlemen, zero has long history. Okay, it's not from Middle Eastern. It's from India. Okay, the history of zero in mathematics history is a huge chapter on its own. It took Indian philosopher, yogi, Indian pundit to find out what zero is. Zero has long history. Okay, so it's a very philosophical concept, and it's not an easy number to deal with. Number zero. Okay, it took Indian to figure out what the zero is. Okay. Very philosophical, because in mathematics it's a taboo to divide by zero. Okay, why? I'll tell you why. Okay, so we cannot quite define 0 over 0 as 1. Yeah, it makes sense, right? You pass 0 to the other side, 1 times 0 is equal to 0. Yeah, fine. How about this? 0 is equal to 2 times 0. Then you pass 0 again. 0 over 0 is equal to 2. Now, 1 is equal to 2. Okay? That's why we don't divide some number by 0, because from here on, 1 is equal to 2, equal to 3, equals 3, equal 4, 4 equal 5. The mathematical universe collapses like that. Okay, so we cannot do this, all right? So maybe it's impossible to express this z function into a single equation, okay? So, but still, we want to distinguish non-zero number and number 0. We want to find out there's one distinction between these two classes of numbers. Is it 0 or non-zero? Okay, that's all we are trying to find. And it's not that easy, okay? I'm not sure if it is even possible algebraically or Boolean algebraically, okay? I'm not sure, all right? Boy. What's the difference between 0 and non-zeros? It's like this, okay? 0 plus 0 plus 0 is always 0, okay? But if you have number 2, yeah, 2 plus 2 equal 4, right? How about 0 times 0? Yeah, so always equal to 0, okay? We have 3, okay? 3 plus 3 is equal to 6. 3 times 3 equal to 9, right? Yeah, if it's non-zero, it increases or decreases or alternate, okay? Minus 3 times minus 3, 9. Minus 9 times, 9 times minus 3, minus 27. There's some changes, but 0 never changes, okay? What is 0 to the zeros? Okay, is it 1? What the hell is this? So yeah, 0 is a very special number, okay? It's oddball. 0 is like oddball, okay? All we want is to find one single simple one-line equation that reduces all non-zero number to 1 and keep 0 to 0. That's what we are trying to do. We are going to ask God. God, are we asking too much? Hmm? That's all we are asking. Please. Give us one single equation that would convert non-zero numbers into 1 and 0 to 0. Give me that equation. Give me that function, please. An algebraic or Boolean algebraic or some combination of the two. Okay, please. In Jesus Christ's name, we prayed. Amen. That's what we are asking. Is it too much to ask? I mean, we are not trying to make money or trying to get laid. We're just doing mathematics here. Why do you have to? Why do you have to give us such a hard time? Hmm. I think it's impossible. Okay, so in computer programming, we have some computer programming language that interprets like this. Okay, compile a program. Okay, if it's non-zero, then it's true. Okay, if it's 0, then it's false. We have some computer programming language like that, like C language. Okay, so but algebraically, I don't think it's possible. Okay, even with Boolean algebra. Okay, um, because zero zero over zero, that's undefined for the right reason. Okay, we cannot define because 0 over 0, okay, it can be 1, it can be 2, it can be 3, because 0, you pass this denominator over to the other side. Yeah, 0 is equal to 1 times 0, 0 is equal to 2 times 0, so it can be any number. That's why it's undefined. Okay, it's for the right reason, right? So boy, so we cannot just divide I'm just taking the time because in this TV screen, I mean this laptop screen, we have this timer, right? So, man, I'm losing my voice too. We gotta wrap this up very quick. Okay. Maybe we should throw in this dynamic variable time. Okay, time variable, right? How about infinity? Infinity is like 1 over 0, right? 1 over 0 is infinity, right? So, ah, boy. Maybe we should introduce this concept of infinity, okay? Oh. Okay. What if we multiply some number? Okay. 0 times 2 is equal to 0, okay? But if it's some non-zero number, some a, okay? A times 2 is 2a, okay? And we divide that by 2a. How about that? Now it's still 0. And now this is 1. How about that? Okay? Whew. Okay. We may have got it. We are not sure yet. Okay. We'll see. How about this? Z of x is equal to x times 2. Okay? Oh, we cannot divide by 0 though. Oh. We're just spinning the wheel here. Oh boy. We cannot divide by 0. Because in computer programming, okay, algorithm has this time element. Okay, sorry. If it's zero, then we can stop. Or if it's non-zero, yeah, we can further divide by number itself. So we can make it to one. If it's zero, we can stop there. Okay, it's algorithmic. Oh, this algorithm, like yes or no, yes, no. Yeah, algorithmic chart, right? We can do that in computer, okay? But in mathematics, it's not that simple. Okay. But we can inject some time function, throw in another variable. Okay, so it's still possible. Maybe we need one more variable, multivariate function. Okay. Oh boy. I'm out of it. Okay, I have no idea. Can you help me? I have no idea. I don't have a clue. I don't have a clue. Well, to make a non-zero number into one, to reduce some number like 3 into one, we have to divide like 3 by 3. But problem with that approach is that we cannot divide by 0. Okay. How about like 2 to the x minus 2 to the x? Wow. 2 to the x divided by 2 to the x. Okay. You remember this? Yeah. Plus, plus, -1, -2. You remember that? We covered this long time ago, okay? Maybe it's that, okay? Um, okay, well, but we still have to distinguish these two. But so, ah, okay. We still have 30 minutes left, okay? So we have time, okay? So let's not give it up, right? Oh boy. We know this, okay? A minus A is equal to 0, okay? So you can reduce any number to 0. Now, if A is not 0, let's say B is not non-zero number. B divided by B is 1, okay? So that's the conversion formula between algebra and Boolean algebra, which is 0 and 1, okay? So we know that much. How can we distinguish 0 and non-zero number? Okay. If x is 0, x multiplied by 2 or any number is always x, okay, because x is 0, okay. If x is non-zero, 2 times x is not equal to x, okay. Maybe we can do some logical function instead of Boolean function, instead of algebraic function. Maybe some logical function, okay? Yeah, we can do that. Okay. Logical function, all right? Yeah. 2x is equal to x. If this is true, okay? I think we got it. Okay? Yeah. If x is equal to 0, then yeah, 2x is equal to x. Okay? Okay? X is equal to 0, then 2x is equal to x, right? Then this is true, which is 1. 1 logical negation is 0. Okay. If x is not equal to 0, let's say x is equal to 3. 2 times 3 is 6. Is it equal to 3? No. Okay. So this logical value is 0. False. 0 logical negation is 1. We got this. We got it. It took such a long time, but we got it, okay? Oh boy. Oh, how about this? What an idiot I have been. I'm sorry, I'm such an idiot. How about this? X is equal to 0. Negation of that. Logical function, okay? It's in logic, mathematical logic, okay? Boolean logic. It's a statement. When if this statement is true, it's 1. Boolean logic, okay? If the statement is false, it's 0. True or false, okay? So x is 0, 0 equal to 0, true. So this is 1. 1 negation of 1 is 0, okay? If x is not equal to 0, like number 3, 3 is equal to 0, no. So Boolean value is that is false, 0. Logical negation of 0 is 1, okay? We got it. Finally. Ooh. Okay. So delta, canonical delta ij is equal to negation of okay. Negation of okay. Yeah, this is a zx, okay. I minus j. I minus j is equal to 1, which is equal to I is equal to j, okay? That's it. If I is equal to j, then it's 1. If I is not equal to j, then it's false, it's 0. So, yeah. That's Kronecker delta. I'm sorry it took so long. It looks simple, but it was very difficult. Okay, so Kronecker delta is this. Okay, Kronecker delta. We're gonna use black. Okay. Kronecker delta ij is equal to I equal j. Okay, that's it. If I is equal to j, then it's 1. It's a Boolean algebra. Okay, logical function, mathematical logic. I is equal to j, then 1. If I is not equal to j, then it's 0. Okay. Boolean function, logical mathematical algebra, mathematical logic is that if the statement is true, then it's 1. If this statement, mathematical statement, is false, then it's 0. Okay, so 1 and 0. Okay, we got it. Why did it take so long? It was not easy journey, okay, but we got it. Okay, so congratulations and thank you. Okay, now we have that. Okay, so now we have this spiky function, sampling function. Okay, we got it. Okay, we have sampling function here. Ooh. Let me drink some water. We have sampling function, okay? From here to here, here to here, we have function f1. Here to here, f2, okay? x0, x1, x2, okay? Wee, okay. How do you define this function, generic function f, without any subscripts, okay? f1 if x is between x0 and x1, okay? f2 if x is between x1 and x2, okay? That's our next step, all right? So you'll be like f is equal to f n multiplied by this should be Boolean function, okay? X is between x and xn minus 1. The Boolean function is a true or false, like 0 or 1, okay? Let's plug in the number, okay? When n is equal to 1, f is equal to fn, f1, when x n is equal to 1, right? So x0 and x1, x0 and x1, okay? Yeah. When, and what if all the other value? Yeah, well, it's false, so it's 0, okay? When n is equal to 2, okay? Let's see. When f is equal to 2, let's see. It's more like collection of that, okay? So should we be like sigma? Not sure. Maybe it should be like sigma over n, something like that, okay? I guess it's like union, okay? Set union, all right, over n is equal to 1, 2, whatever, okay? So function f is a collection of sub-functions, okay? It's a union when n is equal to, well, it's a set of sub-function. Function f is a set of sub-functions, okay? I is equal to 1 to n, okay? Function I multiplied by x I minus 1 x x I, something like that, okay? Because if x fall outside of this boundary, this interval, okay, it's 0, okay? If x happen to fall into this interval, yeah, then it's this function, okay? Now we are collecting one by one, okay, sub functions. We are combining them. That's the resultant function f, okay? I think this is a good equation, okay? So yeah, we have set theory, Boolean algebra, and traditional algebra. We are combining all this shit together. We got our shit together, okay? It took very long time, but it was worthwhile, okay? So congratulations, all right? Okay. Man. We have to satisfy ourselves with this, okay? Can you read all this? I hope you can. Okay. Oh my goodness. I'm tired. I'm hungry. Okay, so but we got it. Alright? I'm gonna write this over here so that you can see it. The sampling equation, okay? F F, okay, is equal to union, all right, set theory union. Okay, I is equal to 1 through n. 1 through n sub function, this sub function, okay, this sample, okay, interval, all right, fi multiplied by this Boolean function, okay, x I minus 1 x I, okay. If x happen to be within this interval, okay, like I is 0, right? So f1, if x is between x0 and x1 when I is 1, okay, yeah, then yeah, it's f1, okay. Otherwise, if x fall outside of this interval is 0, so 0 times fi is always 0, okay. So yeah, you have this f1 right here. Now, union set theory union operator when I is equal to 2, okay, f2 times 1 or 0, okay. If x is fall between I is equal to 2, so I minus 1 is 1, right? Between x1 and x2, then yeah, it's f2. Otherwise, it's 0, okay? I think it could be, this union can be sigma, okay? Because it's 0 plus f2, 0 plus f1, so yeah, it's sigma, okay? Yeah, so union, yeah, it's we don't need set theory here. We just need this Boolean algebra here and just algebra, okay? Because it's if x fall outside this interval, it's all 0, okay? Okay. But if this x happen to fall inside of this interval, then yeah, it's this guy become 1 and it's f1, okay. But if x happen to fall outside of that, then this guy is false, you know, so it's 0, okay. Yeah, beautiful equation. I've never seen anything like this before, so it's a discovery, okay. All right. Yeah, it's kind of dizzy. Okay, it's not an easy equation to understand, but it is. I think it's correct. Ah, maybe it's not correct. I don't know. I don't know. At least it's our first attempt. Okay. Maybe we should keep the union instead of sigma because fx is not equal to f1 plus f2, f3. No, that's not true. Okay. I guess we are not done yet then. Okay. Ah, boy. So you have 2 minutes left. Okay. This is f1 times x0 x x1 plus f2 times x1 x x2 and blah blah blah. Let's see if that's true. Okay, let's see if this is 0 1 2. Okay, what if x is like 0.5? Okay, if x is 0.5, yeah, 1, I mean 0 1 1 2. If x is 0.5, yeah, this guy is 1, this guy false, so you wipe this out. Okay, so yeah, this is 1, so f1 correct. What if x is 0 1.5? This guy wiped out, all the other guys wiped out too. Okay, 1.5 here, yeah, so it's f2. Actually this equation is correct. Okay, because you have f3 multiplied by Boolean equation x2 x x3. Okay, if x is 1.5, yeah, this guy is wiped out, and you have only f2 left, and this Boolean equation is 1. You got it. Okay, thank you. Good night.